I'm very pleased to be with all of you here today at the first Climate Robotics Summit. Now, every day we really want to have an impact, whether it be with our friends and family, in our communities, in our lives, and in our whole world. It is clear in this growing climate robotics network that we are driven by evidence, by science, by technology. Now, in my work, I often say people before data. And when we need we need data and we need to be guided by ethical principles, as Patrick rightly pointed out, and responsible data practices. We must include people on that journey and truly seek to understand which data we need and how we might use it. Today, we are joined by Ed Carr online, as well as a video from Katharine Hayhoe. Both will share about the state of climate science and what they consider the higher priorities. And I'd encourage you to use the chat to tell us what you think the priorities are as we're having this conversation. Now, as mentioned, Katharine Hayhoe is unavailable today, but she did kindly give us a video so that we could learn a little bit more about her impact and her work. But I did want to tell you just a bit about her in introduction as we wait for Ed to join us as on stage as well soon. Katharine is a Canadian atmospheric scientist. She studies climate change by crunching data and analyzing models and helping engineers, city managers, and ecologists quantify the impacts. Professor Hayhoe is currently focused on establishing a scientific basis for assessing the regional to local scale impacts of climate change, both on human systems and on our natural environment. She is a Paul Whitfield Horn Distinguished Professor and an endowed chair of Public Policy and Public Law at Texas Tech University Department of Political Science. And in 2021, Professor Hayhoe joined Nature Conservancy as the chief scientist. I hope that you will enjoy more about her work, and we'll share a link in the chat for you. And definitely do read some of her work and some of her videos. But now let's hear directly from Katharine in a video that my colleague will play for us. Thank you.
Hi, my name is Katharine Hayhoe. I am a climate scientist and also chief scientist for the Nature Conservancy, and I'm delighted to be with you here today to answer 3 short questions. Question number 1, what are the most pressing climate issues based on the latest climate data and science today? Well, what we see when we look at our climate today is that it is changing faster than any time in human history, and pretty much any time as far back as we can go in the paleoclimate history of this planet. 55 million years ago, the most rapid period of warming that we have detailed records for in the Earth's history, we estimate that only 1/10 of the carbon was going into the atmosphere naturally, year by year, that we're putting in today. So one of the most pressing issues is to understand the massive impact that humans are having on our climate, as well as on our biodiversity, the nature on which all of our life depends. And that flows directly into the next question, which is, how might robotics play a meaningful role in collecting data? There is so much that we still do not understand about our planet. It is as complex as the human body. There are so many places where we don't have long-term observations. Even though satellites have given us that eye in the sky in recent years, there is still so much to observe, and from those observations, build an understanding of how our actions are impacting this planet and how our interventions could mitigate the risks that we've created ourselves. So question number 3, what is my hot take on the climate space? Here it is, and I'm delighted to be asked this question, may I say. So many people are still convinced that if more people understood how scary this issue is in terms of ice sheets, polar bears, slowing ocean circulation, record warm ocean temperatures, if more people just understood how extreme the changes are that we're seeing in our climate today are, they would take action at the scale needed to fix it. Unfortunately, psychology, social science, neuroscience, all of that tells us that's not the case. We need to understand not only how bad it is, which I think of as the head, we need to understand why it matters to me, to my life, my home, the place where I live, the people and places and things that I care about. And then we need to understand not only the heart, but the hands, what I can do to make a difference to help fix it. So in effective climate communication, even though I'm a climate scientist and I could talk all about the extremes that we're seeing around the world, I tend to focus what I talk about on what's happening in places where people live that they can see and identify with, and always pair that with information on what each of us can do to help make a difference. Because I know that we cannot fix this problem alone, but I'm absolutely convinced that we can fix it together.
Wonderful. Well, I'm glad that we were able to hear from Professor Hayhoe. And Professor Clark, thank you so much. Carr, thanks so much for joining us. Now, Professor Ed Carr is the U.S. Center Director at the Stockholm Environmental Institute. Now, Ed, you've worked on many strategic policy items, including the IPCC. I'd like to hand over to you to tell us a little bit more about your background and then just your thoughts on what we should prioritize. And we have a bit more time for Professor Carr. And if you do have questions for him, please do put those in the chat, and we'll come back to them in a little as we listen to Professor Carr speak. Go ahead, Professor Carr.
Thanks very much. So my area is the social dimensions or social science of climate change, principally around climate change adaptation. I'm going to speak to what's going on within that realm. And within that realm, I see three pressing issues. And much of what I'm about to say is going to resonate strongly with things you heard from Patrick at the start. The first of these is the need to move beyond just discussions of biophysical risk. Much of the work on climate today focuses on the measurement of biophysical risk. The likelihood will be impacted by some manifestation of climate change. However, people's vulnerabilities are determined by social and structural issues, such as economic or gender inequality. Climate change plays out on those structures to produce or exacerbate vulnerability. Put another way, vulnerability isn't about temperature and rainfall. It's about what those variables impact that produces vulnerability and drives people's behavior. We need to find new and more effective ways to merge the social science of vulnerability with the science of biophysical risk to build a path to a future we want to live in. The second issue is understanding people's needs for adaptation. Contrary to what a lot of people seem to think, it is a bad bet to assume that decontextualized maximization or efficiency will drive human behavior. Income or even food supply may not be as important as other considerations, such as maintaining the social order. I have very good data to back this up. In coastal Ghana, I've demonstrated that men carefully control the size of their wives' agricultural plots to ensure that women can make their contributions to the subsistence needs of the household without generating any surplus. Why? Because women own that surplus, and they're very good at using it to purchase goods for resale in the village, leveraging a small amount of agricultural income into a large amount of money. This creates a problem because in this part of the world, men are expected to earn more than their wives, and those that do not face a wide range of sanctions that can even include loss of access to agricultural land. The result? Households are producing less food and income than they might, all in the name of maintaining the existing gendered social order. In this context, then, a man heading a household might be eager to adopt a technology, but he might want it because it ensures he will stay in charge of the household, not because it's really that much better for producing food or income. We need substantial investment in developing this level of understanding of the social structures and individual motivations of those whose needs we hope to address with climate action. The third big issue is getting past resilience as a normative goal. Resilience is often cast as good in climate conversations, and more resilience is more good. There are two reasons why this framing is problematic, at least an uncritical take on this is problematic. First, you have to be careful what you make resilient. For example, when you make a farming system resilient, you generally make the social relations in that system resilient too. Consider the example of the Ghanaian farming system I just brought up. If we uncritically make that system more resilient, we are likely making those gender inequalities resilient, which undermine all sorts of other development goals. Second, we're past the point of incremental changes to address the challenges posed by climate change. We need transformative changes in how we live in the world to get to a just and sustainable future. That's not just my opinion, that's the opinion of the IPCC and the opinion of IPBES, two large global environmental assessments. This means moving past a notion of resilience as what we have, forever bouncing back from shocks and stressors, as what we have, that is, our assets, our way of life, our way of consumption, is often the source of both climate change and the underlying structures that create vulnerability to climate change. Instead, we need to start thinking about forgiving systems that allow us to adapt and transform in helpful, deliberative ways that move us toward shared goals. I raise all of this to highlight the importance of the social context in which any technology, including robotics, might be introduced. As Patrick referenced in his opening remarks in the context of humanitarian work, it's also true that in the world of international development and now climate change adaptation, the landscape is littered with great technologies that nobody adopted because they did not speak to that context.
Wow. Thanks, Ed. I'm really glad that you're mentioning the just who has the power to make things and who are we making things with. That really, we don't want to replicate the inequity that already exists. And I think as we go on this climate robotics journey, or in any kind of thing, I want to mention that as such a priority. I know Patrick mentioned it and yourself as well. And I'm just so happy. I've been at so many technology conferences where it's not underlined immediately. So just thank you. Now we do have some time for questions for Professor Carr. Please do put those and type those in the chat, but I'll start off if I'll take the privilege of that. So, Katharine really underlined the real paradox of behavior change and impact on climate change. And I think you also highlighted to that attribute as well. You mentioned in a recent video that we need to go fast and act transformational. Now we are here at a Climate Robotics Network conference or a summit, and there are some realities that we need to balance in terms of science and this enthusiastic innovation approaches. So maybe you could give some recommendations on how do we act transformationally over with ethical guidance.
Yeah, thank you for that question. I think the most important thing, and again, I feel like I might be echoing Patrick a little bit here, but that's good. I want to underline some of the things he said. We have to remember that when we're working in the climate space, there's almost no way in which you're not going to be impacting people, and there's almost no way you're not dealing with social and political issues. And Patrick said that very clearly, and I really appreciated that. There is no such thing as a purely technical, apolitical intervention here. That said, we do need to start moving very quickly. I agree with Dr. Hayhoe. The world is not going to end in 5 years. That language is very, very unhelpful. But the window for us to act is narrowing very quickly. So we need people to start moving fast in terms of innovation, but they need to do so with a deep concern for that precautionary principle kind of thinking that says, right, if this doesn't work, who would be harmed by it? How can we redress those harms? How can we avoid those kinds of harms? Also, last point on that, I expect things not to work. Things don't work all the time. It's about learning from stuff not working. That becomes really critical. If you're in a zero fail kind of situation, you're not going to get us to where we need to be. So in some ways, this is a very exciting space to be in, as long as we can keep those precautionary principles in place.
Right. We have another question for you. How do we balance that need to act fast without breaking things? Because it really is a dynamic for sure. And there's no truth serum here for it, but definitely, how would we balance that?
One of the ways in which you can act fast without breaking things is to actually understand what you're interacting with. So again, I work in the adaptation space more than the mitigation space, but even in the mitigation space, you are still dealing with people, right? If you want to conserve a forest to uptake carbon, somebody lives near or in that forest, and you need to be paying attention to that. It is through developing really serious understandings of those people, their situations, their motivations, that you can design interventions that work in that context, as opposed to trying to impose change upon that kind of a context. That said, again, you still have to be very, very wary of what's happening. I wrote a paper recently with a colleague. This is my favorite academic title ever. I can't believe they let me get away with it, which is What to Expect When You Have No Idea What You're Expecting, which is how to think about monitoring, evaluation, and learning under deep uncertainty. And I think we need to take on that kind of thinking this deep uncertainty thinking, and how we're going to be looking for the impacts of the things that we do beyond the normal modes, right? Of just saying, oh, I did A and expected B to happen. Did that happen? Well, that's good, and we need to be doing that. But what about all of the things you didn't expect to happen? How are you going to be looking for those unexpected outcomes, good and bad, and learn from them?
Wonderful. Yeah, definitely do no harm. But I think a real deep listening of the communities that we work with and
Yes.
building with rather than on. I think I really, really appreciate you mentioning that. What are some of the current active projects that you're working on, or that, and you mentioned a paper. I would love very much if you would drop that link in the paper, in the Slack, in the chat afterwards. We're all big consumers of information here, so definitely it's your audience. So can you give some examples on what you're working on currently in this regard?
Yeah, so I've got a lot of different things going on, but I'll just quickly describe probably the big project that I suspect will eat up the next decade or more of my life. I spent my career looking at what I would call small producer systems. So small farmers, small fishers are starting to become an issue, that sort of thing. Mostly looking at how folks cope with global change, not just climate change, but also attendant economic change, other forms of environmental change. One thing that's become a concern for me is the way we talk about these systems under climate change. We keep acting as if they are first driven principally by biophysical variables. That was sort of my first comment there. If you look at a lot of studies of this, everyone talks about, oh, well, in 2025 or 2050 or whatever year, the precipitation will change by this much, the temperature will change by this much, therefore this crop won't germinate and the system will fail. This presumes that those farmers will just sit there pounding away at the same crop until they keel over dead, which never happens. The farmers adapt their behavior along the way, and we have relatively little information about that. It's not well integrated into these understandings of possible system failure. On top of that, we also treat all these systems as if they'll be local humanitarian crises. But these producer systems are tied into global systems. 84% of the farms on planet Earth are small farms. 40-odd% of our food comes off of smallholder farms. Astonishing amounts of our food, at least the foundation of our global food system, comes from there. We may not be directly eating from smallholders, but we are eating in a system that is underpinned by smallholders. So the ones that go away, some of them will be local humanitarian crises, and we need to be ready to respond to that. Others pose systemic risks. We have no idea which is which. And I'll be spending a lot of time trying to figure out which is which, and then developing ways of understanding who's under stress, when they might reach a failure point, and how we can think about transformation with those communities and the people in those systems to transform them towards sustainability.
Yeah, and I'm a granddaughter of farmers, so I would say that they have a lot more power to innovate with very little, and with mindset. We have one more question from Burke before I have my final question for you. So in the current paradigm of for-profit robotics, and believe me, I really like all the shiny things. Let's talk about Atlas later. What kind of strategies should be employed with the robotics engineers to help mitigate the social risks that you're mentioning? So whether they're young engineers starting out or people more established, what are the kind of parameters that you would set up for that? Over.
I don't know that I can set up parameters, but I do have a suggestion, and it's partnership, 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 partnership. There are tons of social scientists out there working on this issue. We sort of dominate the adaptation space at this point. There are lots of people interested in collaboration. I'm never going to be an expert on robotics. It's not my area. On the other hand, I can't expect someone who's great at robotics to suddenly become a social scientist overnight, right? It takes decades sometimes to develop the kind of skill set you need to really do this work well. So I would just plead for partnership, respectful partnership on both sides of this, right? There are a lot of social scientists who I think are sometimes too dismissive of technology. We're going to need technologies to deal with the climate challenge. On the other hand, I feel like there are a lot of technologists who say, hey, we've got a solution. Why do I have to listen to people? I see that happen all the time. That is your shortest route to failure, folks. I promise you, your project will fail, and you will probably hurt people in the process. And I assume that anyone on this kind of a call doesn't want that outcome. So partnership, and that's with me. I know that Rob Kruger's on this call somewhere, people like Rob. There's lots and lots of people in this space who are really interested in working alongside scientists and engineers to make this kind of thing work.
Yeah, I would say that training engineers right from the get-go, that ethical response is understanding we must not bifurcate our knowledge. We must, again, I'm never going to be a social science expert. I am a technologist, but I think it's really important that we have those spaces where people are a little bit more multidisciplinary, which is why I enjoy this network. Can we have one more question from the chat? And I'd ask maybe Ed if you're staying on just to answer some of the ones that come in after, if that's all
Sure.
right. So how do we ensure that these issues of equity and social vulnerability are addressed in these technical innovation spaces? So what are the kind of the tactics that we can use in that regard?
This is incredibly challenging. There's all kinds of problems. It's hard to answer this in a short way. I mean, if you got a couple of hours, we could wade into it, but I'll give you the quick version of it. One of them is to think about the composition of your teams. Diverse teams aren't just a political statement, folks. They bring different viewpoints to the table, and those different viewpoints become incredibly important in thinking about design and implementation and measurement of what you're doing. So I would argue simply for thinking intelligently and carefully about diversity of all kinds, intellectual, background, all of that. I have found that to be incredibly effective in my own lab. In terms of the bringing that in practice, again, I think I'm pleading for partnership. There is no simple way to uncover the kinds of things you need to know to really address issues of equity and diversity and people's diverse needs for this kind of technology without bringing serious social science to the table. So you're going to need to develop partnerships to do that well. There's simply no way around that I can see.
You hear that? Everybody wants to partner with Ed today. How exciting. So Ed, we'd like just before we end, a little bit of a hot take on these priorities, right? There's the things that we say, the things that we publish, but what as you're landing on perspective, perhaps you could just close with that.
Yes, sure. Those who know me know that I'm sort of a walking hot take, so I'm going to try to just focus a tiny bit here. Here's what I'd like to put out to everybody here, and this is definitely bridges both the social and the technology space. And that for me is a thing I've been saying for years. I'm not scared by what I know is coming in the climate space. The human race is remarkably innovative, and when we choose to focus and throw resources at an issue, we often find ways to address it. What I'm worried about is what we don't know and may not be able to know is coming. We've added a spectacular amount of energy to the Earth system, and we are toying with a massive, highly complex system in unprecedented ways. Complex systems, when you put them under this kind of stress, start behaving in really unpredictable ways where small disturbances can become massive system impacts. This presents tremendous challenges, I would think, in this technology space, because, for example, what's useful and impactful today could be beside the point in relatively short order, depending on how quickly these systems change around us. So I think there's something that I find terrifies some of my natural science colleagues. And then the qualitative social scientists like me are just like, yeah, this is how it should be. So maybe that's a bias. But instead of chasing false precision and investing massive time and money in tiny reductions in uncertainty about how the world works, we're going to need to spend a lot more time thinking about how to operate under deep uncertainty going forward if we're going to ensure that we're investing in durable solutions and approaches that get us to anything that looks like a just and sustainable future.
Yeah, understanding uncertainty, having patience, and calling a friend. It sounds like we need to have better partnerships for that journey. So just again, thank you, Professor Carr, for spending some time with us. He did have some other questions in the chat, so hopefully you'll answer those and share a paper with us or two, and follow him on LinkedIn as well as Professor Hayhoe. Just thank you again for talking about climate science and the priorities. And I want to hand it back to Patrick, and let's get on with the next part of the show. Thanks again, everyone.